Okay, one more type of an example that you're going to see. Is this. Determine the eccentricity, type of conic, and the directrix. So this time we're given an equation, and we need to come up with the E, the directrix, and what type it is. Okay, so we've got R equals 6 over 1 plus 2 times the cosine of theta. Okay, so first things first, I want to look at this first number here in my denominator. Okay, it's a 1. That's good. We want it to be a 1. All of our 4 standard orientations have 1 as that first term in the denominator. Okay, so that's good. Always check that. That means that we can look here and we can find our E value. So our E value is 2. Okay, so E is 2. 2 is greater than 1. Okay, if it's greater than 1, that means we're going to have a hyperbola. So now we just need to find the directrix. Okay, this is a plus, so we're going to have something equals a positive number. This is a cosine. Okay, if it's a cosine, we're going to have a vertical directrix, and that's x equals. So we're going to have x equals some positive number. To find out what our k value is, we look at our top. Remember, this is k times e. I know my e is 2, so if I set 6 equal to 2 times k, that means our k has to be 3. So x equals 3 is our directrix. Okay, let's look at another example real quick. Okay, same directions. R equals 42 over 7 minus 5 times the sine of theta. Okay, this one. When I look at this first term, that is not a 1. So we need to, before we do anything else, we need to make that a 1. So I'm going to divide both the top and the bottom by 7. Alright, when we divide both the top and the bottom by 7, we get 6 over 1 minus 5 sevenths times the sine of theta. Okay, now we've got that 1 there. So we've got our eccentricity there, 5 sevenths. That's less than 1, so that tells me it's going to be an ellipse. Okay, now we just need to find our directrix. We've got subtraction, so that's going to be a negative. We've got sine, so it's going to be y equals. So we've got y equals a negative, and let's factor out our e from that 6. And we're going to get